Okay, we are now ready to define the definite integral. So the definite integral will give us the exact signed area. That means that it could be a negative value if our function is below the x-axis. So exact signed area between a continuous function f of x and some interval on the x-axis. So let's suppose that f is continuous and f of x is defined on the interval from a to b along the x-axis. Then when we form the Riemann sum, which remember it is a sum where we are adding areas of rectangles, where we have picked some value within an interval to evaluate the height, and we multiply times the width of each subinterval. And when we take the limit as the number of pieces in our subdivision goes to infinity, or as the width of each rectangle goes to 0, this defines our definite integral from a to b of, now we write f of x dx. So let's talk a little bit about this notation. The definite integral is the same, the integral symbol is the same as what we use for the indefinite integral, but this is called the definite integral because we have limits of integration. And it's an elongated S, really that represents a sum. A to B, those are the bounds along our x-axis, and these are called the limits of integration. So this is along the x-axis. F of x represents the height of each rectangle whose area we're finding, and this dx is the differential of x, which means really it's an infinitesimal quantity, and it's represents the infinitesimal width of each rectangle that we're summing. And this is basically analogous to delta x, except in the limit this becomes arbitrarily thin. So it's an infinitesimal width of each rectangle. Now sometimes if we partition the interval from a to b on the x-axis, where the widths of each subinterval might not have equal lengths, so maybe I decide to kind of willy-nilly subdivide our interval from a to b, then we call the longest interval that we've subdivided a to b into, we call this the norm. The length is the norm of the partition. So norm of p means partition, and norm are these double bars, and this just means the length of the longest subinterval along the x-axis. And I'm defining this way because sometimes we might write our limit of the Riemann sum as we did above, as the number of subintervals goes to infinity of the sum from k equals 1 to n, f of x sub k delta x sub k for the kth subinterval, but we might also write this as the limit as the norm of this partition gets arbitrarily small. So when the longest subinterval approaches 0, all of the shorter ones, the length of the shorter ones, will also get close to 0. And so we might also write the definite integral as the limit of the Riemann sum when the norm of the partition approaches 0. So you could also see it written this way. And this is still our definite integral from a to b of f of x dx, remembering that this means the exact area between our function and the x-axis between a and b. So one thing to consider and to remember is the difference between an indefinite integral and a definite integral. The notation's very similar. Right? But for the definite integral, we'll always have limits of integration that correspond to endpoints of an interval on the x-axis. And f of x dx corresponds to the area of a rectangle that we're using to obtain the area under our function in the limit. And the indefinite integral does not have any limits of integration, but looks quite similar. And so you might recall from our videos that the indefinite integral represents a family of functions that have the same derivative. So it's a family of antiderivatives whose derivative is the function that's in the integrand. So here you will get functions, and you'll always have like a plus c to represent an infinite number of functions that share the same derivative. And with the definite integral, this represents exact signed area. And when we look at the properties of the integrals, we'll talk more about what I mean by signed. But this is a number, and the family of antiderivatives is a family of functions. So there's a difference in the result of calculating a definite integral, which is a numerical value representing area, and a family of functions, which is the indefinite integral. So this was our definition of our definite integral.